A weightless thread can bear a tension up to 3.7 kg weight. So this is the maximum tension a string can withstand. A stone of mass 500 gram is tied to it and revolved in a circular path of radius 4 meter in a vertical plane. So this is a problem in the vertical motion of a particle. If g is 10 meters, then the maximum angular velocity of the stone will be. So they are asking for the maximum angular velocity. So if a particle is moving in a circular path, maximum angular velocity, so what is the maximum tension we will calculate? So for the formula for the tension is equal to mv square by r plus, actually it is mg cos theta, but for maximum angle we will put it as simply it is mv square by r plus, for maximum take it as 1, so t is equal to mv square by r plus mg. So what is v square by r? We can go for calculation of v square by r from here. V square by r is equal to t by m minus g. T is given as 3.7 by mass is given as 500 grams or the 0.5 kg, we can say, minus g. So 3.7 by 0.5, so it's going to be 74 minus 10, so 64 is the v square by r value. So v square by r value is 64. So we can calculate from here what is v. So v square or v is equal to square root of 64. One more minute. We'll calculate not like this, isn't it? So v square equal to 64 into r. R in this case is given as 4 meters. So v square equal to 4 into 64. So v is a square root of 4 into 64. Root of 4 is 2. Root of 6 is 8. So root of 64 is 8. So answer is 16 is 2 into 8. So velocity is 16. So they are asking for a maximum angular velocity. The question is about the maximum angular velocity. Angular velocity, the formula is angular velocity equal to v by r. So here v is given as 16, r is given as 4. So it is simply 4 radians per second. So answer is 4 radians per second. So this is 4 radians per second. A is the answer. So it is simply calculating first v square by r from tension and then going for a angular velocity. So we will move on for the next case of circular motion.